Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll understand the basics of system design for machine learning. So, when you build a machine learning model, it is not possible to have that particular model in your system and make people to use your system to do inference. So, basically, what you have to do is you have to host that particular machine learning model on a web server, and that web server will be accessible to different users based on the requirement. Now, with that in mind, let's get started with single server setup, and then we'll discuss about database, and then we'll talk about scaling. So single server setup is nothing but you have one system. When you are starting off with a POC, you normally start within your personal system, and then you try to build a simple web server using Flask or Fast API and create a simple routes such that you can communicate with that particular endpoint. So let's understand, right, what is the basic thing that happens when you're trying to hit a particular website, okay, in the backend. Okay. So consider you are a user and who is using a web browser or a mobile app and trying to hit a google.com. So it goes to DNS, which is domain name system, which contains the mapping between this particular google.com with an IP address. Now this IP address is fetched and it is sent back to web browser or a mobile app. Now then it uses something called as HTTP protocol and tries to hit the IP address and reaches the web server. The web server, what it does is it tries to fetch the HTML, corresponding HTML for the specific route, and tries to render it on your browser or a mobile app. So there are two sides to it. One is the user side and there is the web server side. The user side is normally the client side, which is nothing, uses technologies like HTML and JavaScript. And on the web server side, you have technologies like Java, Python, and other technologies that helps you build a web server. And one of the thing that the communication that happens between these two, right, it's normally or widely used format is JSON, which is nothing but request response that is taking place between these two systems, which is nothing but user and web server. Now let's go to database. Okay, so when you are building a system, you also need some location where you want to store the information that you are taking in your application. For example, if you have a login page where you are using username and password, okay, you are taking these things from the user in the web mobile app or a web browser. So these details need to be stored somewhere in your system in the web server or in on the specific location called as database, okay, which is normally used for storing information. Now database can be what can be included into the same web server as the application code is, which is not highly recommended because you cannot scale both of them independently. So it's widely recommended that you run your web server or app code separately from the database server such that you can scale them independently. And there are two types of database. One is relational database and there is non-relational database, and relational database is nothing but stores data in a table format and rows and columns. Okay. The examples are SQL and Postgres, and non-relational database are used for non-structured data and structured data in a key value format or a document format. Examples are CouchDB, Cassandra, MongoDB. So all those comes under non-relational database. So as I said, you have to independently keep your database and away from web server independently, such that you can scale them independently. So some of the actions that happens whenever you hit a particular web server, there is some, if you're passing the information of your username and password, it has to create a record or update the password, or you have to delete the user. Okay, so all these can be actions can be taken care by the web server, and it can be replicated on database, and you can read information from database. For example, if you are looking into the homepage of your Facebook, you get the news feed and it has to fetch the data from the database. Okay, that's what read refers to here. So when should we use a non-relational database, right? So consider you want to do real-time inference on your machine learning model. So you need super low latency while doing that. Okay. So in such cases, you can use non-relational database. And also when you have unstructured data like images and audio files, then you can go for non-relational database. And also when you want to just serialize and deserialize the data, then also you can move to non-relational database. And also once more, if you want if you want to store a massive amount of data, then also you can use non-relational database. Okay, so with that, what we'll do is we'll go to scaling. Scaling is nothing but you have built a single server setup. Now the number of requests are increasing and your web single server is not able to handle that. Then you have to scale your server to multiple servers, and that's when you want to what scale it. Either you can do horizontal scaling or you can do vertical scaling. So what is horizontal scaling and what is vertical scaling? So horizontal scaling is nothing but currently you have one system, okay, one system with one CPU and one RAM, okay. Now you can build another, you can what connect with another system, and you can also connect with multiple systems, okay, which will have its own CPU and RAM. Okay, you will have multiple CPUs, multiple RAMs, okay, all in different systems, and your request that comes in, it can be passed to any of these systems, and the response can be fetched from any of the system. Okay, that is horizontal scaling. When it comes to vertical scaling, consider you have a single system. Okay, currently it has like cores, four CPU cores and 8 GB RAM. Now what you'll do is when the number of requests are increasing, you try to increase the CPU and RAM of that particular system. So it can be what understood here. So horizontal scaling, you have one system. When the number of requests are increasing, then you have bunch of systems. Okay, when it comes to vertical scaling, okay, currently you have 4 cores and 8 RAM, 8 GB RAM. When the parallel request comes in, you increase the number of cores and you increase the number of RAM. Okay, that's how the scaling works in both these. The major drawback of what vertical scaling is, you cannot keep adding more cores into the single system. So there is a hard limit of number of cores you can add or number of RAM you can add to this particular system. Okay. But also one of the major point to understand between horizontal scaling and vertical scaling is in vertical scaling you have one system. Okay. So if it goes down, your whole application goes down. But when it comes to horizontal scaling, if a system goes down, the request can be sent to the other system which are present in the cluster. Okay. It can avoid the single point of failure. So we have seen bunch of things in this particular video. One is scaling, one is database, and the other is single setup, single server setup. Okay. So with that, I'll be concluding this video, and let's in the next video I'll be talking about load balancer, which will help you to understand how the routing of request happens, how the traffic is segmented across different nodes. Okay. So with that, I'll just conclude this video. Thank you so much.